Hello everyone, my name is Francesco. I'm a postdoc and a Hawking Fellow at the Department of Physics in Cambridge. I am the researcher in charge of the project that we called Gravitational Waves, a Path to the Big Bang. I developed this project in collaboration with Morgane Billault, who did an impressive job in trying to convert my ideas into an animation. It's really amazing to see how one page or two of written notes suddenly came alive. The project described in this animation consists in trying to build a community of researchers who are interested in working on gravitational wave physics in a range of frequency that has not been explored very much so far, because there is no known astrophysical source giving rise to a signal in such a frequency range. However, as explained in the animation, this frequency band could become one of the most interesting ways to discover new physics and to learn about the early universe in the future. There is quite a bit of work to do in this direction though, because the currently existing technology is not good enough to detect such feeble gravitational waves. But we shouldn't be too discouraged. It took 50 years from the first attempts to the first detection of gravitational waves in the frequency range probed by LIGO, Virgo and Kagra. I am developing this project in collaboration with other scientists from all over the world, including Professor Fernando Quevedo, who is based in Cambridge. If you want to have more information about it, please visit our website and our YouTube channel, where you can find all the talks of the conference on this subject that we recently organized. Have fun with the animation, and thanks again for watching.
Hi, my name is Morgane Billault. I made the video in collaboration with Francesco Muia. Our collaboration started with a script written by Francesco that included the key points of his research. From the script, I started sketching and writing down my first ideas. The next step was making a storyboard, which is the script put into a sequence of images. From there, I made an animatic, which is the storyboard made into a video. I illustrated a few key scenes from the story to choose the final designs and color palette. To fit the budget of this project, I decided the best tool will be After Effects. I could build my assets and animate them within the same software and speed up my process. From my initial sketches, I built the scenes and animated them following the timing of the animatic. I learned so much during my collaboration with Francesco. I enjoyed the challenge of directing an animation on a subject I was not familiar with. Learning about his research changed my perspective on where we stand in the history of the universe, and I'm excited for future discoveries.
"14 billion years ago, the universe underwent a gigantic expansion called inflation. After inflation, the universe was a hot and dense soup of particles, including protons and electrons. Photons, the particles of light, kept bouncing off with no way to escape, like you do in a metro station on a busy day. The early universe was opaque to light, and we can't observe it with normal telescopes. So there's no way to observe the beginning of time? Well, after inflation, a series of catastrophic events are thought to have happened. For instance, it's believed that the universe changed states several times, in the same way as boiling water transforms from liquid to gas. These events are called phase transitions. Cataclysmic events, like phase transitions and many others, produce gravitational waves in the early universe. Gravitational waves are space-time ripples analogous to waves in a pond when a stone is thrown in. They squeeze and stretch space-time as they pass through. As the gravitational interaction is tiny compared to the others, gravitational waves aren't stopped by the dense plasma in the early universe. They go through it as ghosts through a wall. Gravitational waves are hard to be spotted and were discovered only recently by the LIGO experiment, when a signal from the merger of two huge black holes caused a variation of the distance between two mirrors placed 4 kilometers away of only a fraction of the size of an atom. There are several experiments already looking for gravitational waves. LISA, an antenna placed in space, will be able to detect gravitational waves produced up to this point in time. Detectors LIGO Virgo, and Cagra already probe for earlier epochs. We are now looking for new ideas to detect gravitational waves from even earlier ages. We are starting a challenging journey that will maybe lead us to finally listen to the sound of the very early universe. Enjoy it with us.